Now, what is periodic trends in the modern periodic table? When properties of the element, when properties of element in modern periodic table is observed in modern periodic table, is observed in certain regularity is regularity in their variation. Variation is seen. This is known as periodic trends. So this is known as periodic trend. तो पीरियोडिक ट्रेंड्स क्या होता है, जब भी अपन प्रॉपर्टीज़ एलिमेंट्स ऑफ जो प्रॉपर्टीज़ जो रहता है एलिमेंट का, वो मॉडर्न पीरियोडिक टेबल में जब भी अपन कंपेयर करता है, इस कंपेयर्ड टेबल इज कंपेयर्ड we observe certain regularity in their properties. तो कुछ उसमें जो चेंजेस होता है वो एकदम रेगुलर होते जाता है, जो चेंजेस होता है, और इस चेंजेस को बोलते हैं पीरियोडिक ट्रेंड्स. नाउ दिस ईयर यू विल बी स्टडिंग पीरियोडिक ट्रेंड्स ऑफ ओनली 3 properties. Of 3 properties. What are they? That is, first one is valency, second one is the atomic size, what changes are observed in this, and the third one is metallic and non-metallic characters. Now the first one, that is valency. Now what is valency? Valency is determined. Valency is determined. How is the valency determined? By the number of electrons. Number of electrons present in their valence shell. In their outermost shell or valence shell. That is, it depends upon the valence electron. It depends upon the valence electron. तो वैलेंसी किसके ऊपर डिपेंड करता है? जो वैलेंस इलेक्ट्रॉन है, मतलब जो इलेक्ट्रॉन्स आउटर मोस्ट शेल में रहता है उसके ऊपर डिपेंड करता है वैलेंसी. जैसे कि अगर मैंने सोडियम लिया, इफ़ आई टेक सोडियम, now what is the atomic number of sodium, which we have studied last year also? Sodium, the 281 it is. So in the first shell it is having 2 electrons, in the second shell it is having 8 electrons, and in the last shell it is having only 1 electron. So we know that it will be stable. The sodium is not stable because it is having only 1 electron. It should have at least 8 electron in its outermost orbit. So it is short of 7 electrons. So what it will do? It will either take 7 electrons or it will give away 1 electron. If it gives away 1 electron, this outermost orbit will go away, and this will become the outermost shell, which is having already 8 electrons. So what is easier, to give away 1 electron or to take 7 electrons? So it is very easy to give away 1 electron. So sodium will give away 1 electron. So how many electron did it give away? It gave away 1 electron. Therefore the valency of sodium will become what? 1. Now if you remove the outermost shell, now this outermost, now it will be having only 2 shells. Now this outer shell is already having 8 electrons, so it becomes stable. So this is how valency is determined. Now if I take chlorine, So in sodium it gives away 1 electron. So if I take chlorine now, in the first shell it is having 2 electrons, in the second shell it is having 8 electrons, and in the last shell it is having 7 electrons. 1, 2, 3, 4, 5, 6, 7. Now it needs one more electron to make the outermost shell complete. So it needs all the atoms needs at least in the outer shell it should have 8 electron. Now it is short of 1 electron. So what it is easier, to give away the 7 electron or to take 1 electron? So it becomes easier to take 1 electron. So chlorine will take 1 electron and becomes stable. So by taking 1 electron, the valency of chlorine will also become 1. So if you see in sodium, sodium gives away 1 electron. 1 electron. Therefore valency is how much? 1. And chlorine takes 1 electron. Takes 1 electron. Therefore valency is what? 1. So here it is giving away 1 electron, that is why it is 1 valency, and it is this chlorine is taking 1 electron, therefore the valency is 1. So from the valence electron we can determine what is the valency of that particular element. Now remember one thing, now just now I said the outermost shell should have 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Now 8 is complete. It will not take any electron, neither it will give away any electron because it is complete. Now the middle one is 4. So whatever the valence electron, now if an element is having valence electron 1, 2, 3, then this 3 will give away the electrons. So the one element which is having valence electron 1 and an element which is having valence electron 2 and an element which is having valence electron 3. तो यानी अगर कोई भी एटम में अगर लास्ट शेल में 1 इलेक्ट्रॉन है या 2 इलेक्ट्रॉन है या 3 इलेक्ट्रॉन है, वो हमेशा दे देता है, लेता नहीं है, वो दे देता है. तो इसका वैलेंसी क्या रहेगा? इसका वैलेंसी 1 रहेगा, इसका वैलेंसी 2 रहेगा और इसका वैलेंसी 3 रहेगा. फोर्थ वाला जो है, जिसका जो एटम में 4 इलेक्ट्रॉन्स रहता है, वो देता भी नहीं है और लेता भी नहीं है, वो शेयर करता है. तो इट शेयर्स द इलेक्ट्रॉन. ना 5, 6 एंड 7, ये जो एटम्स में लास्ट शेल में 5 इलेक्ट्रॉन हो, 6 इलेक्ट्रॉन हो, 7 इलेक्ट्रॉन हो, वो कभी देता नहीं है, वो लेता है. इट टेक्स इलेक्ट्रॉन्स. It doesn't give away, it takes electrons. So the valency of this will be how much? How many electrons it will take? It will take 3 electrons, so the valency will be 3. This will take how many electrons? 2 electrons, so the valency will be 2. And this will take how many electrons? Only 1 electron. For example, chlorine I had shown just now. So the valency is 1. So remember this, the first, if the atom is having 1, 2 and 3 electrons, it will give away. And if the atom is having 5, 6 and 7 electrons, it will take electrons. So depending upon how much this will give away 1, so valency will be 1. This is 2, so valency will be 2. And this is having 3 electrons, so the valency will be 3. Here it is just the opposite. It will take 3 electrons, so valency will be 3. Here it will take 2 electrons, so the valency will be 2, and here it will take 1 electron, therefore valency will be 1. So this way valency of an atom or an element is determined. For example, I'll show over here. Sodium electronic configuration, atomic number is 11, so electronic configuration is 281. So valence electron is how much? 1. So valency is also 1. Next one, 282. So what is the valence electron? 2. So valency is what? 2. Aluminum electronic configuration is 283. So valence electron is what? 3. So valency is 1. Here it is 284. Valence electron is 4. So the valency is 4. It does not give or it does not take. It shares the electron. Now in next one, phosphorus 285. Valence electron is how much? 5. Here the valency is what? 3, because it will take 3 electrons from some other atom. Here the electronic configuration is 286. Valence electron is 6. So valency is what? It will not give away 6 electron. It will take 2 electron. So the valency is 2. Here it is 287. The valence electron is 7, so it will take 1 electron, therefore valency is 1. Here it is 2, 8, 8. It is having 8 valence electron. Since its outer shell is completely filled, so it will neither take any electrons nor give away 1 electron. So valency of this is what? 0. So 0 group is having valency always 0. Now periodic trends of modern periodic table. When properties of elements in a group or period in modern periodic table is compared. What do we observe? So if you observe the properties of elements in group or in period and it is compared, then what we observe? We observe certain regularity in their variation. So when you study the properties, कोई भी properties elements का group में या period में पड़ेगा और उसको compare करेगा तो उन आपस में बहुत variation रहता है, मगर वो variation में regularity रहता है. या तो वो increase एक regular variation से होता है या decrease और regular variation से होता है. तो ये इसको बोलता है the periodic. So this is known as the periodic trends of modern periodic table. So this is known as the periodic trends of modern periodic table. Now this year you will be studying the periodic trends of 3 properties of elements. What is the first one? We'll be studying about the first property, periodic trend of which property? Of valency. And the second property, the periodic trend of the second property. Which is the second property we are going to consider? That is atomic size. And the third one is metallic. Metallic and non-metallic character. Metallic and non-metallic character. तो इस साल 3 प्रॉपर्टी पीरियोडिक ट्रेंड्स ऑफ तीन प्रॉपर्टीज का पढ़ने वाला है. कौन सा 3 प्रॉपर्टी? वैलेंसी, एटॉमिक साइज, मेटालिक एंड नॉन मेटालिक कैरेक्टर. Now we will study about the valency. Next I will explain about the valency. What variation, regularity in the variation can be observed in the valency. Now the first property which shows a periodic trend is a valency. What is valency? Valency is determined by the number of electrons in their outermost shell. In the outermost shell. आउटरमोस्ट शेल का मतलब क्या है? लास्ट शेल. जो एटम का लास्ट शेल रहेगा उसको आउटरमोस्ट शेल भी बोलता है और वैलेंस शेल भी बोलता है. दैट इज वैलेंस इलेक्ट्रॉन. द वैलेंस इलेक्ट्रॉन. तो वैलेंसी कैसे डिटरमाइन करता है? जो इलेक्ट्रॉन, कितना नंबर ऑफ इलेक्ट्रॉन लास्ट शेल में रहेगा या आउटरमोस्ट शेल में रहेगा या वैलेंस शेल में रहेगा, उसको बोलता है वैलेंसी। नहीं तो आउटरमोस्ट नंबर ऑफ इलेक्ट्रॉन आउटरमोस्ट शेल में रहता है, उसको वैलेंस इलेक्ट्रॉन भी बोलता है। सो दैट इज हाउ वैलेंसी इज डिटरमाइंड। व्हेन आई विल सॉल्व दिस यू विल अंडरस्टैंड। नाउ ऑन पेज नंबर 24 there is a question, what is the relationship between the electronic configuration of an element and its valency? So answer is this only. Now what is the meaning of this, that the valency is determined by the number of electron in the outermost shell? Now let us take sodium. You had studied last year about sodium, the electronic configuration. What is the atomic number of sodium? That is 11. So what is the electronic configuration? 281. So if I draw the structure, so in the first shell it will be having 2 electron, in the second shell it will be having 8 electrons, 1 2 3 4 5 6 7 8, and in the last shell it is having how many electron? One electron. So valency is determined by the number of electrons. So number of electron in the outermost shell. So in sodium, how many electrons are there in the outermost shell? 1. Now we know that outermost shell should have 8 electron, but here it is having only 1 electron. If it is not having 8 electron, then that particular element will not be stable. So in order to make this stable, we should accommodate 8 electron in this. So how can sodium make itself stable? So it can make itself stable either by giving away 1 electron or by taking 7 electron. तो ये अपने आप को स्टेबल कैसे बना सकता है? या तो 8 इलेक्ट्रॉन आउटरमोस्ट शेल में कैसे ला सकता है, या तो वो 1 इलेक्ट्रॉन दे देगा या तो 7 इलेक्ट्रॉन लेगा। तो आसान कौन सा है? 1 इलेक्ट्रॉन देने में आसानी है कि 7 इलेक्ट्रॉन्स लेने में आसानी है? तो इट इज़ ऑलवेज ईजी। आसान कौन सा है? 1 इलेक्ट्रॉन देने में ज़्यादा आसान है। तो सोडियम जो है वो दे देता है, इट गिव्स अवे 1 इलेक्ट्रॉन, इट गिव्स अवे 1 इलेक्ट्रॉन। तो इसने सोडियम ने कितना इलेक्ट्रॉन दे दिया? 1 इलेक्ट्रॉन दे दिया। 1 इलेक्ट्रॉन दे दिया, इसके लिए वैलेंसी उसका क्या रहेगा? 1. So valency will be what? 1. Why it is having valency 1? Because it gave away 1 electron. Now when the sodium gives away 1 electron, the outermost shell will become the second one, not the third one. Now if you see, the second one is having 8 electrons, so it will become stable. Now if I take the example of chlorine, so chlorine's atomic number is how much? Chlorine's atomic number is how much? 17. So what will be the electronic configuration? 2 8 7. So if this is a nucleus, first shell will be having 2 electron, second shell will be having 8 electrons, and the last shell, that is outermost shell, will be having 7 electrons. So it is having 7 electron. तो outermost shell में क्लोरीन में कितना इलेक्ट्रॉन है? 7 इलेक्ट्रॉन है, मगर कितना रहना चाहिए? 8 रहना चाहिए। तो या तो वो 7 इलेक्ट्रॉन दे देगा, नहीं तो 1 इलेक्ट्रॉन लेगा। So either the chlorine will give away the 7 electron or it will take 1 electron. So which is easier? It is easier to take 1 electron rather than giving away 7 electron. So chlorine will take 1 electron or will accept 1 electron. So when it accepts 1 electron from some other atom, the outer shell will be having 8 electrons. Since it is taking 1 electron, so the valency is what? 1. So it depends upon, so now you must have understood that valency is determined by the number of electron in its outermost shell. So valency is, how it is valency is determined? How much electron is taken or how much electron is given. According to that, the valency is determined. Now you know that there should be 8 electrons for in the outermost shell. 1 2 3 4 5 6 7 8. The 8 electron, the atom which will be having 8 electron is completely stable. Which is the middle one? Fourth one is the middle one. Now 1 2 and 3, that is if an atom has 1 electron in its last shell or 2 electron in its last shell or 3 electron in its last shell, they will always give away. They will give away the electron. So the atom which is having 1 electron will give away 1 electron. So valency will be what? 1. The atom which is having 2 electron in its last shell will give away the 2 electrons. So the valency will become 2. The atom which is having 3 electron in its outermost shell, it will give away those 3 electrons. So the valency will become 3. But 5, 6, 7, it's not like that. 5, 6, 7, if an atom is having 5 electron in its last shell or 6 electron in its last shell or 7 electron in its last shell, it doesn't give away, it takes electron. It will take electron. So the atom which is having 5 electron in its last shell, it will take how many electrons to make itself stable, or to make it 8? It will take 3 electrons. So the valency will be what? 3. 6. The atom which is having 6 electron in its last shell, it will take 2 electrons to make itself stable. So the valency will be what? 2. And the atom which is having 7 electron in its last shell, it will take 1 electron. Therefore the valency will be what? 1. And the one which is having 8 electron, it doesn't give nor it takes, because it is already having 8 electron. And the middle one, it doesn't give nor it takes, it shares. And the valency, it will share how many electrons? 4 electrons. And the valency of this will be 4. So that is how the valency is determined, by the number of valence electron in its outermost shell. Now for example, sodium, the third periodic table, in the periodic table, the third period, sodium atomic number is 11, so electronic configuration is what? 2, 8, 1. What is a valence electron? 1 is a valence electron. So what will be the valency? It will be 1. Magnesium atomic number is 12, so the electronic configuration is 2, 8, 2. So the valence electron is 2. And the valency will be 2. In aluminum, it is 2, 8, 3, because atomic number is 13. The valence electron is 3. Therefore, the valency is 3. In silicon, it is 2, 8, 4. How many valence electron it is having? 4 valence electron, and the valency is 4. Phosphorus, 2, 8, 5. Valence electron is 5, so the valency is what? Over here it is not 5, it will take 3 electron, so the valency is 3. Next one, 2, 8, 6, valence electron is 6, so it will take 2 electrons, so the valency is what? 2. Here it is what? Which we had already discussed, 2, 8, 7. The valence electron is 7, it will take 1 electron, therefore valency is 1. Here it is 2, 8, 8. Valence electron is how much? 8. It doesn't have to take any electron, nor it has to give away 1 electron. So the valency over here will be 0. So this is how the valency is determined. Now these are the questions which are given on page number 24. First question we had already discussed before. The second question, the atomic number of beryllium and oxygen is given. Beryllium is how much? 4 atomic number, and oxygen of atomic number of oxygen is how much? 8. You have to write down the electronic configuration, and from the electronic configuration find out the valency. Now beryllium atomic number is 4, so in the first shell it will be having 2. And the remaining 2 electrons will go in the next shell. How many valence electron it is having? 2 valence electron it is having. Therefore, valency will be what over here? Valency will be 2. Why 2? Because we had studied before only I had explained those atoms which are having 1, 2 or 3 valence electron, it will always give away those valence electron. तो पहले ही डिस्कस कर चुका था कि जिसके पास, जो एटम के पास 1, 2 या 3 वैलेंस इलेक्ट्रॉन रहता है तो वो हमेशा देता है. इसके पास कितना है? बेरिलियम के पास 2 है तो 2 वैलेंस इलेक्ट्रॉन दे देगा, इसके लिए उसका वैलेंसी 2 रहेगा. ना ऑक्सीजन atomic number is 8. In the first shell it will be having 2, and in the next shell it will be having 6. So what is the valence electron over here? 6. So we had discussed those atoms which have valence electron 5, 6 and 7. It will not give away, it will take electrons. Since the valence electron over here is 6, so it will take how many electrons? It will take 2 electrons to make itself stable. Therefore valency will be what over here? Valency will be 2. Why 2? Because it takes 2 electron. तो ये जो एटम के पास 5, 6 या 7 रहते हैं वो हमेशा देता नहीं है, लेता है. तो इसके पास 6 है, ऑक्सीजन के पास 6 है, तो कितना लेगा वो? 2 इलेक्ट्रॉन लेगा. इसके लिए वैलेंसी 2 है. अभी इफ़ यू कंपेयर बेरिलियम एंड ऑक्सीजन, वैलेंस इलेक्ट्रॉन इज 2 over here and valence electron is 6 over here, but yet both are having valency 2. Why? Because here it gives away the 2 electron and here it takes 2 electron. Now next, write in the table write in the table the first 20 elements according to the modern periodic table. Below the symbol you write down the electronic configuration and write the valency. So now I have shown you how to remember the names of the 20 elements in the modern periodic table. So sentence you remember, that is high, Henry, little, Benny, boy, caught, naughty, ozone, fighting, Nelly, Nana. Magnesium, always, sings, pop, songs. Clothes are kept casual. So this is how you are supposed to remember the name of the first 20 element. Here in 10th standard you have to just remember the name up to the 20 elements only. Now what is the atomic number of hydrogen? 1 it is. Now it will go serially, the atomic number will go serially. This is 1, this is 2, this is 3, 4, 5, 6, 7, 8. So atomic number will go according to the serially only. So what is the electronic configuration over here? 1. It is having 1 valence electron, so valency will be what? 1 over here. Next one, helium. 2 valence electron is there and the valency is 0 over here. Why 0? Because in the first shell it can accommodate only 2 electrons. So helium has 2 electron and the first shell is complete, that is it has completed its duplet. So the valency is what? 0. It doesn't take any electron nor it gives away the electron. Lithium is 3 atomic number, so electronic configuration is what? 2, 1. So the valency is what? 1 over here. Beryllium is 4, so 2, 2, valency is 2. Here it is 2, 3, valency is 3. Here it is 2, 4, valency is what? 4 over here. So valency is 4. I'll just write down the valency in red color so that you'll be able to distinguish. And this will be 0. Next one, 2, 5. So what will be the valency over here? 1, because it will, not 1, 3, sorry, not 1, it will be 3. Why? Because it will take 3 electrons, so the valency will be what? 3. Here oxygen, it is what? 2, 6. So valency will be what? 2 over here, because it will take 2 electron. We had discussed over here. Next is 2, 7. So valency will be what? 1 over here, because it will take 1 electron. Next one is 2, 8. It is already having 8 electron. So here valency will be what? 0. Next one, sodium. 2, 8, 1. So what will be the valency over here? 1. Next one, 2, 8, 2. What is the valency over here? 2. Next one, 2, 8, 3. So what is the valency over here? 3. Next one, 2, 8, 4. So what's the valency over here? 4. Next one, 2, 8, 5. Since it is having valence electron 5, so it will take 3 electrons. Next one, 2, 8 and 6. So its valency will be 2 because it takes 2 electron. Next one, 2, 8, 7. What's the valency over here? 1. Here it is 2, 8, 8. Since it is having 8 valence electron, so valency will be what? 0 over here. Next one, 2, 8, 8, 1. So what's the valency over here? 1. 2, 8, 8, 2. So what's the valency over here? 2. So this is how from the electronic configuration you can find out the valency also. Now what is the periodic trend in the variation of valency while going from left to right within a period? So what variation, periodic trend? We were discussing about the periodic trend, the first property of valency. What is the periodic trend in the valency? So what periodic trend you find in the valency while going from left to right in a period? They have said that see in the period 2 with reference to period 2 and reference to period 3. In both this period 2 and period 3 you find while going from left to right within a period, period 2 and period 3, what do you find? First the valency goes on increasing from 1 to 4. तो पहले वैलेंसी इंक्रीज होता है जब भी अपन पीरियड में लेफ्ट टू राइट जाते हैं, 1 2 3 4. सो द वैलेंसी increases from 1 to 4 and then it decreases to 0. So when you go from left to right, first it increases 1 2 3 4 till 4, then it starts decreasing 3 2 1 0. Now what is the periodic trend in the variation of valency while going down a group? When you go down a group, you will find all the valencies are same. Why? Because the valence electrons are same. So while going down a group, the valency remains same. As valence electron is same. In group 1, they have asked with reference to group 1, what do you find? Group 1, the valency is what? 1. And in group 2, the valency is what? 2. Valency is 2. And in group 18, the valency is what? 0. Valency is what? 0. You can see over here the valency is what? 0 over here. In group 2 it is 2 2 2. It is same one. In group 1 1 1 1 1. So in a group while going down the valency remains same. Now we had discussed before itself that this year in 10th standard you will be studying the periodic trend of 3 properties, that is valency, which we have already discussed before. Second one is about the atomic size. Now size or volume is a fundamental property of matter. So it's an important property of matter. Now how is the size of atom determined? Size of atom is indicated by its radius. Now what is radius of atom? Now supposing if this is a nucleus. So this is a nucleus, this is the first shell, that is K, this is the second shell, that is L, and this is the third shell, that is M. So K, L, M. Supposing they are having 3 shells with the electrons revolving around it. Then what is radius? The radius is a distance between the nucleus and the outermost shell. This is known as the radius. So what is the radius of an atom? It is a distance from the nucleus up to the outermost shell, that is known as the radius of the atom. So atom is size of the atom is indicated by its radius. And what is radius? Radius is the distance from the center, that is from the nucleus up to the outermost shell. जो size और volume है वो main important property है matter का. और एटम का साइज कैसे इंडिकेट किया जाता है? रेडियस के हेल्प से. नाउ रेडियस क्या है? अभी समझो ये न्यूक्लियस है, ये इसका पहला शेल है, ये इसका सेकंड शेल है और ये इसका थर्ड है. पहला का नाम क्या है? के. सेकेंड का नाम क्या है? एल. और थर्ड का नाम क्या है? एम. सो दिस इज के शेल, एल शेल, एम शेल. अभी मैंने इसमें 3 शेल्स बताया है. तो रेडियस का है न्यूक्लियस से लेके लास्ट शेल का जो डिस्टेंस रहता है उसको बोलते हैं रेडियस ऑफ द एटम. तो रेडियस ऑफ द एटम क्या है? फ्रॉम द न्यूक्लियस अप टू द आउटरमोस्ट शेल इज द रेडियस ऑफ द एटम. नाउ जैसे कि आप लेंथ ऑफ द सेगमेंट का लेंथ क्या है, तो कौन सा यूनिट यूज़ करता है? इफ़ आई वांट टू मेजर द लेंथ ऑफ द सेगमेंट पी क्यू, देन वी यूज़ अ यूनिट सेंटीमीटर. सपोजिंग इफ आई वांट टू फाइंड आउट द डिस्टेंस बिटवीन 2 places, then it is indicated by a bigger unit, that is kilometer, and we have a smaller unit also, that is millimeter, and so on. So same way atom is very small, it is very very small. So the radius of the atom, radius of atom is measured in picometer, which is indicated by the symbol pm. Picometer is smaller than, pm is smaller than nanometer. pm is a smaller unit. Than a nanometer, which you have studied last year. Now 1 picometer is equal to how much meter? Is equal to 10 to the power of minus 12 meter. So this is the way the radius of the atom is measured. It is measured in which unit? In picometer, and picometer is a smaller unit than nanometer. And 1 picometer is equal to how much? 10 to the power of minus 12 meter. Now some elements are given, name of the elements are given on page number 25, and these questions were asked in the year March 2019. So these questions were asked and the answers of these questions are very simple. So whatever is there in the middle of the lesson, any questions are there, you go through those questions and those are very simple, and you understand the lesson also much better by going through those questions or answering those questions. Now elements, oxygen, boron, carbon, nitrogen, beryllium, lithium, and the atomic radius is also given of that particular element, which is in picometer. The atomic radius of oxygen is 66, boron is 88, carbon is 77, nitrogen is 74, beryllium is 111, and lithium is 152. Now by referring to the modern periodic table, so just go through the modern periodic, just see the modern periodic table and find out the period. In which period means this way, left to right. So in which period do you find the above elements? So just see the modern periodic table and see in which period boron, oxygen, carbon, nitrogen comes. So if you see, it comes in the period 2. So it comes in which period? Period 2. Arrange the above elements in decreasing order of the atomic radii. So arrange this element in decreasing order of the atomic radii. So first what will come? Lithium. That is 152. Now next, which is less than lithium? Beryllium. That is 111. Next what will come? Boron. That is 88. Next carbon, that is 77. Next nitrogen, that is 74, and next oxygen, that is 66. अभी ये जो एलिमेंट्स को है, उन लोग ने पूछा है कि ये एलिमेंट्स ऑक्सीजन, बोरॉन, कार्बन, नाइट्रोजन, बेरिलियम अगर मॉडर्न पीरियोडिक टेबल में देखो तो ये कौन सा पीरियड में आता है, पीरियड बोलेगा तो लेफ्ट टू राइट जाता है ऐसा, इसको पीरियड बोलते हैं, और ऊपर से नीचे जाता है तो उसको ग्रुप बोलता है। तो कौन सा पीरियड में ये सब एलिमेंट्स दिखाई देता है, इट इज सीन इन द पीरियड 2। अरेंज द अबव, इन सब एलिमेंट्स को डिक्रीजिंग ऑर्डर ऑफ द एटॉमिक रेडियाई में अरेंज करो। तो लिथियम सबसे बड़ा है 152, उसके बाद बेरिलियम आता है 111, फिर उससे कम वाला बोरॉन 88, उससे कम वाला कार्बन 77 एंड सो ऑन। Does this arrangement match with the pattern of the second period of the modern periodic table? तो ये अरेंजमेंट जो मैंने पहले लिथियम लिखा है, फिर बेरिलियम, बोरॉन, कार्बन, नाइट्रोजन और ऑक्सीजन, क्या इसी तरीके से वो मॉडर्न पीरियोडिक टेबल में पीरियड 2 में दिखाई देता है? तो देखेगा तो पीरियड 2 में फर्स्ट लिथियम ही आता है, उसके बाद बेरिलियम, उसके बाद बोरॉन, उसके बाद कार्बन। तो डज इट कम इन दिस अरेंजमेंट? यस, इट डज कम इन दिस अरेंजमेंट ओनली। सो इफ यू सी द मॉडर्न पीरियोडिक टेबल, the arrangement of all this element is this way only. The first is lithium, beryllium, then boron, then carbon, then nitrogen and oxygen in the period 2. Which of the above element have the biggest and the smallest atom? So which is the biggest atom? Biggest atom, सबसे बड़ा एटम कौन सा है जिसका रेडियस सबसे बड़ा है? वो है लिथियम। और सबसे स्मॉलेस्ट एटम कौन सा है? Which is the smallest atom? The one which is having the smallest radii is the smallest atom. So which is the smallest atom? That is oxygen. What is the periodic observed in the variation of the atomic radius while going from left to right within a period? So when you go from left to right, what periodic trend you observe in the variation of the atomic radius? So वॉट पीरियोडिक ट्रेंड इज ऑब्जर्व, मतलब क्या दिखाई देता है रेडियस में? तो रेडियस क्या होता है, जैसे जैसे आगे जाता है, व्हेन यू गो फ्रॉम लेफ्ट टू राइट द रेडियस गोज ऑन डिक्रीजिंग, सो इट गोज ऑन डिक्रीजिंग। तो जैसे जैसे लेफ्ट से राइट में जाता है तो रेडियस को क्या होता है, रेडियस कम 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 होते जाता है, इट गोज ऑन डिक्रीजिंग। सो वाइल द एटॉमिक रेडियस goes on decreasing while going from left to right within a period. So this is your answer. What do you observe in the atomic radius? The atomic radius goes on decreasing while going from left to right within a period. Now why does this radius decreases? Even though all the elements are having only two shells, not valence, all the elements are having two shells, first, second, all are having only two shells, then why the radius is going on decreasing? The reason behind this is what? As the number of electron, as the atomic radius goes, atomic number goes on increasing. What is the atomic number of lithium? 3, then 4, this is 5, this is 6, this is 7, and this is 8. So as the atomic number goes on increasing from left to right, the size goes on decreasing from left to right. Why? Because an additional electron goes on adding as you go from left to right. Now what happened when an additional electron is added? Now we know that there are only two shells. So the blue color is the two shells in the period 2. So in the first shell it has 2 electrons. Supposing in the last second shell it is having only 1 electron. Now if another electron is added over here, तो पीरियड 2 में कितने शेल्स अब सब एलिमेंट को? खाली 2 ही। तो ब्लू कलर वाला खाली उसके ऊपर ध्यान दो, ब्लू वाला तो 2 शेल है। पहला शेल में समझो, पहला शेल में 2 इलेक्ट्रॉन है और नेक्स्ट शेल में समझो कि सिर्फ 1 इलेक्ट्रॉन है। तो व्हेन वन मोर इलेक्ट्रॉन कम्स इन दिस शेल, व्हाट हैपेंस? द प्रोटॉन्स आर पॉजिटिवली चार्ज, so the protons are positively charged and the electrons are negatively charged. The protons are there in the nucleus, so there is an attraction between the nucleus and the electrons. So when you add one more electron in the outermost shell, what happens? It pulls the shell towards itself because of the force of attraction between the nucleus and the electron. So nucleus और electron के बीच में attraction रहता है। क्यों? क्योंकि न्यूक्लियस के अंदर प्रोटॉन है वो पॉजिटिवली चार्ज रहता है और इलेक्ट्रॉन जो रहता है वो नेगेटिवली चार्ज रहता है। इसके लिए उनके आपस में एक फोर्स ऑफ अट्रैक्शन रहता है। जब मैं और एक इलेक्ट्रॉन ऐड करी, व्हेन वन मोर इलेक्ट्रॉन इज एडेड, क्या होता है ये अट्रैक्शन बढ़ जाता है और ये बाहर वाला रेडियस शेल को अपनी तरफ खींचता है और भी छोटा हो जाता है. सो नाउ व्हेन वन मोर इलेक्ट्रॉन इज एडेड, व्हाट हैपेंस? The shell becomes smaller in size, and so when one more electron is added, what happens? The size of the shell, the outermost shell, becomes small. Why? Because it gets pulled towards the nucleus because of the force of attraction between the electron and the nucleus. तो जब भी एक इलेक्ट्रॉन ऐड होता है तो क्या करता है, वो आउटरमोस्ट शेल को वो खींचता है अपनी तरफ, क्योंकि फोर्स ऑफ अट्रैक्शन बढ़ जाता है. तो फोर्स ऑफ अट्रैक्शन न्यूक्लियस और इलेक्ट्रॉन के बीच में बढ़ता है तो वो अपनी तरफ खींचता है, तो इसका जो आउटरमोस्ट शेल का साइज जो रहता है वो छोटा हो जाता है. सो दैट्स व्हाट इज हैपनिंग ओवर हियर. ओवर हियर इन द फर्स्ट शेल देयर आर 2 electrons, and in the second shell it is having only 1 electron. Next 4 it is atomic, so in the first shell 2 electrons, and in the next shell also 2 electrons. So 1 electron has increased over here, so the size became smaller. In the next one, 2 electrons in the first shell, and in the second shell there are 3 electrons, so the size becomes still smaller. In the first shell there are 2 electrons, and in the next shell there are 4 electrons, so the size becomes still smaller, so it becomes smaller than this. Next one, it is having 2 electrons in the first shell, and in the next electron it is having 5, not shell, in the first shell it is having 2 electrons, and in the second shell it is having 5 electrons. So the size becomes still smaller over here. 2 and 6 electrons in the outermost shell, so the size becomes still more smaller. So the atomic radius, what periodic trend you observe in the atomic radius when you go in a period or from left to right? As the atomic number goes on increasing, the size of the atom goes on decreasing.